Hello everyone, section 12.3, two-way tables and probability. Notice that we have another Easter egg here. Click on this, watch the video. Example 1. There are 16 juniors and 24 seniors on the debate team. Of these, 7 juniors and 19 seniors qualify for the state debate competition. Organize this information into a two-way table. So let's put juniors, seniors, qualified, not qualified, okay, so we have 7 juniors that qualified. There were 16 juniors altogether. We have 19 seniors that qualified. There were 24 seniors altogether. So not qualified, that's 9 juniors and 5 seniors. And if we're going to complete the margins, so the marginal frequencies, it's the frequencies out here on the ends, the margins. So how many qualified? 26. And how many did not qualify? 14. So this is our two-way table with our marginal frequencies. So 26 people qualified, 14 students did not qualify, 16 juniors altogether, and 24 seniors altogether. So that's interpreting. Example 2. 2 psychologists surveyed 478 children in grades 4, 5, and 6 in elementary schools in Michigan. They stratified their survey, taking about 1/3 from rural, 1/3 from suburban, and 1/3 from urban schools. One of the questions asked was whether their primary goal was to get good grades, to be popular, or to be good at sports. Below is a table that shows the counts of the students by their goals and gender. Okay, so we can see 117 boys said that their goal was to get good grades, 50 boys said that their goal was to be popular, 60 boys said that their goal was to be good at sports, for a total of 227 boys, so on and so forth. Okay, what's the probability that a student asked is a boy? Well, there are a total of 478 students. And of the 478 students, how many of them were boys? 227 of them were boys. And that's approximately 47%. Part B was the probability the student asked is a boy and the primary goal is sports. So a boy whose primary goal is sports is 60 out of the 478. Or approximately 13%. Part C was the probability that a student asked is a boy given that their primary goal is sports. So we're told that their primary goal is sports. So the total number of students whose primary goal is sports is 90. Of the 90, how many of them are boys? 60. So 60 out of 90, or approximately 67%. Okay, so again, you got to read these questions carefully. Part D, what is the probability that the student's primary goal is sports given that they're a boy? So now we're told that they're a boy. There are 227 boys. What's the probability that their given goal is sports? 60 out of 227. Or approximately 26%. Okay. What is the probability that a selected student wants to excel at sports given that we have selected a girl? So we know that the student's a girl. There are 251 girls. We know that they, what's the probability that they have chosen sports? 30 out of 251. Or approximately 12%. So that is example 2. Example 3. The table below shows the counts of students by gender and grade of students in the mixed DLT class. Begin by filling in the table. So we have a table, but it's not totally complete. In other words, we haven't totaled the margins yet. Okay, so let's fill in the margins. 23 plus 13 plus 50 plus 10 is 51. 15 plus 20 plus 17 plus 2 is 54. So we have 51 boys, 54 girls. 23 plus 15 is 38. There are 38 freshmen. 13 plus 20 is 33. There are 33 sophomores. 5 plus 17 is 22 juniors. 10 plus 2 is 12 seniors. And whether you add across the row or down the column, you're going to get the exact same answer of 105. Now, if you don't, then that tells you you've done an arithmetic error somewhere. Okay. Part A. What is the probability of selecting a student that is a girl? So how many of the students do we have? We have 105 students. How many of them are girls? 54. 54 out of 105 is equal to approximately 51%. What is the probability of selecting a student that is a freshman? So of the 105 students, 38 of them are freshmen. 38 out of 105, or approximately 36%. What is the probability of selecting a girl given she is a freshman? So we know that this person's a freshman. What's the chance of picking a girl? 15 out of the 38 are freshmen are girls. So 15 38ths, or approximately 39%. What's the probability of selecting a boy given that he is a senior? So there are 12 seniors, 10 of which are boys. 10 twelfths, or approximately 83%. Probability of selecting a sophomore given that the student is a boy. So we have 51 boys, 13 of which are sophomores. 13 out of 51, or approximately 26%. What is the probability of selecting a senior boy? So there are 105 students. How many of them are senior boys? 10. So 10 out of 105, or approximately 10%. Okay. Example 4, we're going to use the table that we created in example 1. So we're going to use this table from example 1 to make a two-way table that shows the joint and marginal relative frequencies. So let's go. I'm going to fold this so I can see it. So I'm going to recreate the table here. Qualified, not qualified, juniors, seniors. Only this time I'm not going to be putting in numbers. We're going to be putting in relative frequencies. So what percentage of the students are juniors that qualified? type thing. I should put in here, let's see, 40 students in the debate team. So 7 out of the 40 students are juniors that qualified. That is 0.175 or 17.5%. 9 out of the 40 qualified. That's 0.225. 16 juniors total out of the 40 students. That's 0.4. 19 out of the students are seniors that qualified. That's 0.475. 5 of the seniors did not qualify out of the 40 students. That's 0.125. There are 24 seniors total out of the 40 students. That's 0.6. And there are 26 students that qualified out of the 40. That's 0.65. And 14 of the students did not qualify. 14 out of 40 is 0.35. 40 out of the 40 students are in the debate team. That is a total of 1, which again, if you add across, you get 1. If you add down, you get 1. If you add down, you get 0.65. If you add down, you get 0.35. If you add across, 0.4. Across, you get 0.6. So on and so forth. Okay, example 5 is going to use the same chart. We're going to make a two-way table that shows the conditional relative frequencies based on the row totals. So actually, I'm not using this chart. We're going to use this one. So let's recreate our table again. Qualified, not qualified. Juniors, seniors. This time there's no margins. Okay, we're using the margins. In other words, we're going to do, get my calculator out here. So 0.175 divided by 0.4 approximately equal to 0.4375. Actually, it's exactly equal to 0.375. And then we do 0.225 divided by 0.4, and that one's equal to 0.5625. 0.475 divided by 0.6 is equal to 0.792, and then 0.125 divided by 0.6 is equal to 0.208. And these are our conditional relative frequencies in our table. Example 6. A store surveys customers of different ages. The survey asks whether they would like to see the store expand its toy department. The results given is a joint relative frequencies are shown in the two-way table. So these are our joint relative frequencies. What is the probability that a randomly selected customer whose age is between 10 and 20 would not like to see the store department expand? That is 0.17 by 0.17 plus 0.06 total for this column, or approximately 73 0.9%. Okay, what is the probability they randomly select a customer who would like to see the toy department expand is younger than 10? So less than 10, so we've got 0.27 is less than 10 years old and wants to see it expand. Out of 0.27 plus 0.06 plus 0.23 and approximately 48.2%. Okay, determine whether replying yes and being younger than 10 are independent events. So the probability someone is younger than 10 is approximately 0.36 or 36%. You add these two. Probability that they're younger than 10, given that they answered yes, is so total people is 0.48 because .36 does not equal 0.48. The two events are not independent. All right, example 7. An airline company strives not to lose luggage for passengers. A manager at the company randomly selects 3 flights to check on lost luggage. At the end of each day, the manager determines whether or not there was luggage lost on the flight that day. The table shows findings. Which flight does the best at not losing the luggage? So, based on the sample, probability the flight will not lose luggage is greatest for flight 2. So we have fill out our margins here. There are a total of 13 pieces of luggage in flight 1. There's 14 in flight 2 and 13 in flight 3. No luggage lost, or lost luggage, no luggage lost in flight 1 is 3 out of 13. Flight 2 is 4 out of 14. And in flight 3 is 1 out of 13. And if we do the math here, 3 out of 13, approximately 0.23, 4 out of 14, approximately 0.28, and 1 out of 13, which I really don't even need to check because we know this one's small, 0.07. That's the most number of not lost luggage. So flight number 2 has the highest not lost luggage. Example 8. Below is a table that shows adult American males that have high blood pressure and or high cholesterol. So let's fill in our totals. 61, 35, 96, 52, 44. What's the probability that a man has both conditions? So that they have high blood pressure and they have high cholesterol is 42 out of 96, or approximately 43.75%. What's the probability that a man has high blood pressure? So high blood pressure is 52 out of 96. Or 54.6%. What's the probability the man has high blood pressure if it is known that he has high cholesterol? So he's got high cholesterol. There are 61 that have high cholesterol. What's the probability he's got high blood pressure too? That's 42 out of... Oh, did I skip one? That's 42 out of 61. We'll come back down to that one. What's the probability that a man with high blood pressure has high cholesterol? So high blood pressure is 52, high cholesterol is 42. It's 42 out of 52, or approximately 80.8%. And then let's finish off this one. 42 out of 61 is 68.9%. All right, example 9. The table below shows attendance at a wedding. So let's fill in our margins. 216, 46, 262, 136, 126. Okay, find the probability that a person can attend the wedding. So can attend, 216 out of 262, or approximately 2.4. 16 divided by 262 is about 82.4%. Find the probability that the person can attend the wedding given that the person is in the bride's family. So there are 136 in the bride's family. Can attend is 104. 104 divided by 136 is approximately 76.5%. Find the probability that a person is from the groom's family given that they can attend the wedding. So 216 can attend. 112 are from the groom's family. 16, or approximately equal to 51.9%. Okay, example 10. The spinner is numbered from 1 to 8. Find each probability. So the spinner lands on a 3, given that the spinner lands on an odd number. So how many of these are odd? 4 of them. That's one number out of 4, or 1/4. The spinner lands on a number greater than 5. So that's 6, 7, 8, or 3 of those, given that the spinner lands on an even number. So greater than 5 is 2 even numbers that are greater than 5, 4 of them all together. So 2 out of 4, or 1/2. The spinner lands on 7, given that the spinner lands on a number greater than 4. So greater than 4 is 1, 2, 3, 4, 5 numbers. and I'm sorry, greater than 4. So 4 numbers. Can't include the 4. 4 numbers greater than 4, and one of them is 7. So 1/4. The spinner does not land on a 3, given that the spinner lands on an odd number. So there are 4 odd numbers. 3 of them are not 3, so 3/4, or the complement of part A. Part E, the spinner lands on a number less than 6, so 1, 2, 3, 4, 5, given that the spinner lands on an odd number, so 1, 3, 5, 7. So 3 of the 4 odd numbers are less than 6. And lastly, part F, the spinner lands on a number less than 6, given that the spinner does not land on 1 or 2. So it can't land on 1 or 2. So that leaves 6 numbers to land on. Of those 6, how many of them are less than 6? 3 of them. So 3 out of 6, or 1/2. And that's section 12.3. Thank you very much.